Ratio and proportion. In this chapter, we are going to learn about ratio and proportion. First, let us see what is a ratio. Ratio is an ordered comparison of quantities of the same units. Generally, in our daily life, if we go to market, there we go for some comparison. Say for example, vegetables. We compare which are fresh and which are stale. In the same way, which are expensive, which are of low cost. In this way, we go for some general comparisons. Here, these ratios help for a clear and better comparison with the same or specific units. Let us understand this comparison with the help of an example. Here is a grasshopper and an ant. Now, how do we compare both of their sizes? The length of the grasshopper will be in centimeters. It may be around some 4 to 5 centimeters. Whereas, if you see the length of an ant, it will be around some millimeters. So here the units are different. It is not correct to compare a grasshopper which is in centimeters to the length of an ant which is in millimeters. So in this case, we can compare in a different way. See here, this is the total length of this grasshopper. Now we can put the ants to match with the length of the grasshopper. Now let's see how many ants fit in this length that matches with the length of a grasshopper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 12 ants. So one grasshopper is equal to 12 ants. So this is a better comparison. If we go for just measuring their length, an ant, you say it is 6 millimeters, is to the length is 5 centimeters. 5 centimeters in the sense of 50 millimeters. 6 is to 50. We may not get a proper idea. 6 millimeters. We made this 5 centimeters into millimeters, 50 millimeters. So this is a very big difference. A great difference. Just if we take the lengths, the difference is very high. So we cannot get a good idea. Whereas here we can get a good idea. So this is a better comparison. Comparing quantities with different units. Now let us see, here is a tree which is of a height 13 meters. The height of this tree is 13 meters. The picture of the tree in the book is given with a height of 26 centimeters. So the same tree is printed in a book with a height of 26 centimeters. The actual length is 13 meters. Now, we are going to compare the difference of its height between the actual height and the picture in the book. So we are going for a comparison. It is 13, here it is 26. So can we say that the size of the tree in the book is double to that of this real picture? No, it is not. We cannot say that just by looking at these numbers. We cannot say the height of the tree is double in the book. How is it possible? It is not correct because this 26 is centimeters whereas this 13 is meters. There is a lot of difference. Now we understood one point, that both the values are not of same units. The units are different. Here the units are centimeters, here the units are meters. But before we go for a comparison, both that values must have the same units. So now we make these values to the same units. Here we leave this 26 centimeters as centimeters, but we make this 13 meters to centimeters. So 13 meters is equal to 1300 centimeters. 1300 centimeters. Because we know 100 centimeters make a meter. So 13 meters equal to 1300 centimeters. Now we are going for a comparison. Comparison. Between real tree and its picture equal to 1300 by 26. So what do we get? Here 50 and 1. So 26 50s. So 50 is to 1. We write this comparison like this. The 50 number, it goes to the real tree. The 1 number, it represents the picture. That means the picture given in the book and the real picture. That is the comparison. So the real picture number is 50. The picture in the book is 1. That means the real tree is 50 times bigger than the picture given in the book. 50 times. So here is a clear comparison. Right? 50 is to 1. While writing ratios, we use 2 is to 3, 1 is to 2, A is to B. Here, when we are comparing two different quantities, then we say A is to B. We use is to. And the first term of this ratio is called as antecedent. Whereas the second term is called as consequent. Antecedent, consequent. So we call this as A is to B. Let us see one more example. Here are two children named Ravi and Siri. Both of them have some books. Now let us compare the quantity of books they are having. Siri, she is having 8 books. Siri is telling Ravi has double the number of books than her. So her number is 8 and double the number is 16. So Ravi has 16 books whereas Siri only 8 books. Now let us compare the quantity of books. If we are comparing, if the comparison is between Ravi's and Siri's, here we have to remember the order of comparison. So Ravi's and Siri's, the first one is Ravi. So in our comparison, in our ratio, the first term or antecedent represents Ravi. Here Siri is asked the next. So the consequent or the second term in our ratio represents the Siri's quantity. So Ravi's and Siri's books ratio. So 16 by 8 equal to 1. 2 is to 1. 2 is to 1. So this 2, it represents books of Ravi and 1 represents books of Siri. Here the order remains the same. Now let us see if we compare the books of Siri's with Ravi. Siri's and Ravi. Now the first term is Siri's and the second term is Ravi's. Let us see the comparison of books between Siri and Ravi. So Siri 8, Ravi 16. 1 is to 2. So the ratio between the books of Siri and Ravi is 1 is to 2. Same ratio in different situations. Let us see here two different situations. There is a room of length 30 meter and width 20 meter. Now if we are going to find the ratio of its length to its breadth, ratio of the length to its breadth, length to breadth ratio, that is 30 by 20. Length 30 meters and width 20 meters. So if we take 10 3 times 2 times, so it is 3 is to 2. So 3 is to 2 is the ratio of length to the breadth of the room. Now let us come to the second situation. Here there are some girls and boys who are going for the picnic. Now we are going to find the ratio between the girls to boys who are going to the picnic. The ratio of girls to boys. So girls to boys. The ratio between girls and boys. So girls, first, the first term 24 and the consequent boys 16, 3 and 2. 8 3s, 8 2s. So 3 is to 2. In both the cases, we found the same value. Here the ratio 30 is to 20. Here the ratio 24 is to 16. But in the lowest form, both of these have the same value 3 is to 2. Such ratios are called equivalent ratios. They are called as equivalent ratios. Here these two are equivalent ratios. Now let us try to understand proportion. So what is proportion? Just look at these pictures. Here we have a picture, a circle and a square. So this is a square picture which is having an exact circle at its center. Let us see its measurements. Here it has 3 centimeters width and 2 centimeters height. So this proportion 2 is to 3, or we can write length into breadth 3 is to 2 proportion. So 3 is to 2. Come to the second picture. The first picture is stretched. So what happened here? The size of the picture is changed. So what change do you find? The height of the picture is 2, or the width of the picture is 2 in the first picture and even 2 in the second picture. There is no change. But whereas the length of the picture is changed to 6, that is stretched. So here the ratio is 6 is to 2. And look at the third picture. Here the length is 3, but the width is changed to 4. Actually, it is 2 centimeters in the original picture. Now come to the fourth picture. Here the length is 6 and the width is 4. If you write this in simplest form, 3 is to 2. So here we have 3 is to 2, and here in the simplest form 3 is to 2 ratio. So here the ratios of picture 1 and 4 are same. So we call these kind of ratios, this kind of ratio equality as proportion. So here the picture is resized here exactly to the proportion. This picture's size is changed to big. That is, by maintaining the proportion, by maintaining the exact ratio, the picture size is increased here in 1 and 4. Whereas in 2 and 3, it is not increased according to the proportion. If the ratio of A and B is equal to ratio of C and D, we tell they are in proportion. We write it as A is to B is as to C is to D.